Hello everyone, I'm Darwin. Right now I'll be talking about the problem definition. In the urban waste management crisis, the current challenges are overfilled bins, health hazards, unnecessary emissions, static systems with fixed schedules, which is inefficient, and also lack of real-time data. For the engineering business opportunities, it has multifaceted problems as logistic optimization, IoT and AI integration, and also human behavior dynamics. Well, for the untapped potential, it has smart data-driven solutions, scalable for emerging cities, and also sustainable, which are profitable models. Well, for the path forward, it has tech-enabled solutions, which are IoT sensors for dynamic collection, AI-powered route optimization, and also cost-effective for mid-sized cities. Let's look at the project overview. For core technology, we are equipped with IoT sensors for real-time field level monitoring, centralized AI, analytic platforms, and also predictive collection and dynamic. Well, for the business model, we are equipped with SaaS and subscription, and the clients are city councils, private waste contractors, and for the integration with GIS and fleet management system. Well, for the key benefits are, we'll be talking for cities, 30 to 50% lower operational costs, reduces emissions from optimized truck routes, data-driven policy decisions, and for the residents, it's cleaner streets and no overfill bins, and transparent services matrices. Like for the project viability for the real world data. Example, market validated and also has its demand. Let's look at the objectives right now. The first one is to bridge the gap between technical challenges and market demands by developing an IoT-enabled solution specifically designed for efficient urban waste management. Secondly, is to foster a multidisciplinary approach that combines system engineering software, development, logistics, and also business strategy into one cohesive project. Thirdly, to produce a detailed investment ready business plan that includes all critical components such as customer segmentation, competitive analysis, marketing strategy, operation workflow, and financial viability. Fourthly, to apply advanced business evaluation tools, including break-even analysis, cash flow forecasting, real-time value for money concept to evaluate the return on investment, ROI, and long-term scalability of the product. Lastly, to promote environmental sustainability by offering cities in a way lower fuel usage, reduce greenhouse gas emissions, and also decrease public health risks associated with mismanaged waste. Well, for the benchmarking, our competitive edge, smart waste management system. It has an affordable IoT which has open source customizable hardware, user-friendly simplified dashboard plus SMS alerts, and also AI-powered smarter routing than competitive basic plans. Emerging market focus, local spot teams, and the primary markets are cities and businesses. And for secondary markets, those are NGOs and academics. Thank you.
Hello everyone, my name is Surushan. I'm going to present the SWOT analysis and the key elements of our business model for WasteLink, our smart waste management system, designed to transform urban waste collection through IoT and AI innovation. Let's start with our SWOT analysis. WasteLink's strengths are rooted in its cutting-edge technology. We leverage IoT sensors, data analytics, and AI-driven algorithms to enable real-time monitoring, predictive collection, and also optimized routing. Our cost-effective hardware, built with open-source IoT firmware, reduces manufacturing costs and allows flexible customization, giving us an edge over competitors like Enable. Our user-friendly dashboards are designed for non-technical users, eliminating the need for specialized training. However, as an early-stage venture, we face some weaknesses. Without a proven track record, gaining trust from risk-average municipalities or investors may be challenging compared to established players like Enavo or SmartBeam. Our reliance on IoT software infrastructure, including consistent internet connectivity and also hardware maintenance, could pose issues in developing regions with unreliable networks. Additionally, the significant upfront investment for hardware and software development might strain our finances before we generate substantial revenue. The opportunities ahead are immense. The global smart waste management market, valued at over $2 billion, is growing rapidly by targeting mid-sized and developing cities in Southeast Asia, Africa, and Latin America regions undeserved by competitors. We can capture significant market share. WasteLink, WasteLink aligns perfectly with the global push for smart cities initiatives, appealing to municipalities eager to improve operational efficiency and environmental impact. Partnerships with environmental NGOs, universities, or government innovation funds could unlock funding or pilot programs. Yet, we must acknowledge threats. Established competitors like Enevo and SmartBeam dominate the high-income markets with strong brand recognition. Economic constraints in developing cities could slow adoption even with our cost-effective approach. Cybersecurity risk to our IoT systems or potential hardware failures could undermine reliability and trust. Now, transitioning to our business model canvas, WasteLink is built on a clear value proposition, delivering an affordable, scalable, and intelligent waste management solution. Our SaaS model ensures clients, municipalities, private contractors, and industrial parks receive hardware, software, and analytics with minimal upfront costs. We prioritize customer relationships through localized support and user-friendly interfaces, while our revenue streams come from subscription fees, ensuring financial stability. Key activities include IoT sensor development and AI algorithm optimization and on-ground deployment supported by partnerships with hardware suppliers and smart city initiatives. Our cost structure balances hardware production, software maintenance, and marketing, while our resources, our talented team, proprietary technology, and market insights drive our competitive advantage. Moving to administration, Wastelink's team is structured for success. Our CEO, Darwin Raj, steers our strategy, secures contracts, and builds partnerships with municipalities and NGOs. Our CTO, Siroshan, which is me, leads IoT sensor and SaaS platform development, ensuring technical reliability. Mohammad Amiruddin, our operation manager, oversees field deployment and localized support, critical for emerging markets. Mohammad Esma Azim, our software developer, builds our analytics dashboards, enhancing data-driven decisions. Finally, Mohammad Izul Afif, our administrative lead, manages financial planning, budgeting, and investor pitches, ensuring our business is scalable and also investment ready.
Assalamualaikum and hi everyone. My name is Muhammad Amiruddin bin Zulkifli. So for our operational planning, we outline how WasteLink will implement, scale, and maintain its smart waste management system in target urban environments. So this includes hardware deployment, software development, customer support, logistic coordination, and feedback mechanism, all tailored to mid-sized and developing cities with limited waste management infrastructure. So for phase one, pilot deployment from first month to third month, the goal of this phase is to validate our smart waste management system in a real-world environment. We will start by installing IoT-enabled waste bins in a selected municipality. Then we closely monitor the sensor performance and ensure the data being collect is accurate. At the same time, we'll provide training to municipal staff so they can effectively use the dashboard and receive SMS alert. And lastly, we collect feedback from the user and use it to refine the system. And for the second phase is full-scale implementation from 4 to 12 months. Once the pilot is successful, we will move on to a full-scale implementation. This includes coordinating the mass production and shipping of sensor units. We will also deploy localized installation teams and set up customer support for each area. In this space, our system will integrate with existing municipal tools like fleet routing and GIS. And finally, we'll track key performance indicators like how much we reduce bin overflow and how much we optimize collection routes. And then for the last phase is optimization and maintenance. It's still ongoing. This final phase is focused on long-term system performance and improvement. We will conduct regular diagnostics and push firmware updates to keep the system running smoothly. Our AI algorithm will learn from root and field-level data to become even more efficient over time. We will also support multiple language and ensure that the system works even in areas with low internet connectivity. And throughout this phase, we'll continuously gather user feedback to improve both our hardware and software.
My name Muhammad Izul Afif bin Muhammad Naziruddin. My entry number is CD2100. Okay, today I want to explain about the project finishing objective. The first is the project use a software as a service. It is SaaS module, which means we are earned to discussing income through monthly or yearly subscriptions. On goal is to break even within 2 years by keeping production costs low and maximizing returns, which a scalable and high turn business model. We aim to attract inventory by showing strong financial sustainability and long-term profitability. Okay, next is the main cost of the project. The main cost of the project are divided into several key areas. First, there is a one-time cost of RM 150,000, a lot for hardware development, which involve designing and building the smart sensor used in the system. Then RM 80,000 is allowed for the sensor and no for a software and the dashboard, which will collect and display data from the sensor, along using to monitor and analyze information efficiency. And additional RM 50,000 is budget for installation and training, covering equipment, transportation, setup at its sites, and training local staff to operate the system. For our research and customer is questions, RM 30,000 is set aside for marketing and promotion, including social media, campaign, exhibition, and live demonstrations to ensure the system operates mostly. RM 70,000 per year is need to for operation and technical supports, which includes staff salaries, logistic, and the maintenance. And the lastly is RM 40,000 per year will cover advice and overhead costs such as HR, legal matter, license, and daily internal operation. Next is the revenue projects. Year 1 to year 3. Okay, the first in the year is the project is expense to secure 5 multiple client generation a total revenue of 200,000 through the SaaS as subscription model. By the second year is the number of the client is projected to increase to 15, resulting in a estimate revenue of RM 600,000. And the last is the third year is which to continue growth and the market updation. The project aims to serve 30 clients, brings in a total revenue is 1.2 million. And lastly is break-even analysis. Based on our financial planning, the break-even point for the project can be calculated using the formula. Break-evens equal to fixed cost over to selling price per customer minus to variable cost per customer, which an annual fixed cost RM 150,000, a variable cost of 10,000 per customer, and the selling price is or price of RM 40,000 per customer. The calculation become RM 150,000 per 40,000 minus to 10,000 equal is 5, and the means the project just need 5 customer per year to cover all the cost and break events. Any additional customer beyond this point will contribute directly to profits. Thank you.
Assalamualaikum. My name is Muhammad Isma Azim bin Muhammad Tasrin. My number matrix is CD220059. Now I will present about the time value of money application and calculation. First, the time value of money (TVM) show that money today is more valuable than the same amount in the future due to earning potential. TVM help evaluate the financial viability of the WasteLink Smart Waste Management System over 3 years. And the three key methods I use are present worth, future worth, and annual worth. Okay, second, present worth. Present worth evaluate future cash flow into the value. The discount rate is 10%. Net cash flow is year 1 is 20,000, year 2 300,000, and year 3 800,000. So the total of present worth is 867,346. For future worth, project total value at the end of year 3 is 1,154,200. For annual worth, convert PW into equal yearly return over 3 years. Annual worth is 348,761 per year. And why we use this method? Because PW ideal for investment decision based on current value. For future worth is helps stakeholder estimate long-term return. And lastly, annual worth is useful for yearly budgeting and comparing alternative. As you can see as the summary table, method that we use, value and purpose. Present worth is 867,346 is excess current project value. Future worth 1,154,200 estimate future value year 3. And annual worth 348,761 per year. Compare yearly performance and return. Okay, that's all. Thank you.
Okay, so for conclusion, this project show how engineering innovation can be turned into a practical and profitable business solutions by using IoT sensors, artificial intelligence, and scalable SaaS model. Wasteland directly address a major problem in many fast-growing cities: outdated and inefficient waste collection system. So we have planned every step carefully to make sure the system is cost-effective, flexible from our local needs, and reliable in real-world conditions. Every member of our team has a clear role from building the technology and software to managing finance and working with the stakeholders. We have also included strategies for managing risk, allocating resources, and continuously improving the system over time to ensure it remains scalable and sustainable. From a perspective of engineering economy, we have applied important concepts like break-even analysis, return of investment, and cost optimization to assess the financial side of the project. On top of that, our benchmarking and SWOT analysis have helped us position Wasteling competitively in a rapidly growing market. So in summary, this project is not only a proof that smart waste management is technically and economically possible, it also shows the kind of well-rounded skills modern engineers need today. We're not just solving engineering problems, we turning those solutions into a meaningful real-world impact.